Okay, I think you have finished noting down. Note down the sketch. Is it visible? Tarun, is it visible? Okay,
Yes,
finished
sir. Yes.
noting down the sketch.
Noting is just a second.
Yeah, please listen here now. Please look at the board. Okay, so this is a simply supported beam with central point load, and it is taken as a circular cross section beam or shaft. Okay, so now because of applied load W, this is point A I have taken, that is the upper fiber, this is the lower fiber, I have taken it as point B. Okay, because of applied load W, what will happen to the beam here? It's going to bend something like this, correct? It will bend like this. Okay, then point A is under what type of stress? Point A is under what type of stress? Compression. And
Compression.
point B will be under tensile stress, correct? So now I rotate
Right.
the beam by 180 degrees. Okay, I rotate the beam by 180 degrees. In such case, what will happen? This point B will go to A and point A will come to point B. That is, point B is subjected to compression, point A is subjected to tensile stress. Okay, so alternatively, for every revolution of the shaft, okay, the tensile and compressive stresses keep interchanging. This type of loading is called completely reversed or cyclic stresses, where the magnitude will be same, but alternatively it is subjected to tensile stress and compressive stress. And in completely reversed or cyclic stresses, the mean stress is going to be zero because the magnitude will be same. So therefore, but it is subjected to alternatively tensile and compressive stress for every revolution. The mean stress is going to be equal to zero. Is that okay? Could you get it now? Could you understand?
Yes.
Please take a, please make a
Yes, sir.
note. Consider a rotating beam. Consider a rotating beam. Consider a rotating beam of circular cross section of circular cross section and carrying a load W and carrying a load W carrying a load W as shown in figure. As shown in figure. Full stop. This load induces stresses in the beam which are cyclic in nature. CYCLIC, cyclic in nature. Next line. We can observe that the upper fibers of the beam the upper fibers of the beam, that is at point A, close the bracket there, that is at point A, close the bracket. The upper fibers of the beam are under compressive stress, and the lower fibers of the beam, within brackets, that's at point B, close the bracket there. That is, lower fibers of the beam are under tensile stress, That is initially because of the applied load, right? The upper fibers of the beam are under compression, lower fibers of the beam, that's at point B, the fibers are under tensile stress. Okay. Next line. After half a revolution, next line, after half a revolution, the point B occupies the position of point A, and point A that of B, full stop. Thus, point B is now under compressive stress, and point A is under tensile stress. Full stop. For each revolution of the beam, the stresses are reversed. From compressive to tensile, and tensile to compressive. Next line. The stresses which vary from one value of compressive to the same value of tensile, or vice versa, are known as completely reversed or cyclic stresses. Are known as completely reversed or cyclic stresses. Cyclic stresses. Okay, noted. Nihal Shetty, are you there? Mulepati, Nihal, are you there? You have to be quick, I say. Nihal Shetty, are you there?
Yes, sir.
Increase your voice level, I say.
How do I do it?
Have you noted down or you have not noted down?
I've noted down.
Read the last sentence.
The value of tensile or wait, the stresses which vary from one value
Yeah,
of compressor to the same value of tensile or vice versa are known as completely reversed or cyclic stresses.
right. So that is the magnitude remains same, but cyclically for every revolution it will change from tensile to compressive and compressive to tensile. Okay, that is what is called as completely reversed or cyclic stresses. In such cases, the mean stress is going to be equal to 0. Okay. Otherwise, rest of the analysis is same as what we have been doing. The Soderberg relation is given by KFT sigma A by ABC into sigma endurance plus sigma mean stress divided by sigma yield is equal to 1 by factor of safety. If I replace yield stress by ultimate stress, what I am going to get is Goodman's relation, right? Yeah, note down this problem. The piston rod of a steam engine, make it fast. The piston rod of a steam engine, is subjected to a completely reversed load of 40 kilonewton. Completely reversed load of 40 kilonewton. Completely reversed load of 40 kilonewton. Full stop. The material has an endurance limit of 280 megapascal. The material has an endurance limit of 280 megapascal and an yield strength of 310 Newton per mm square and an yield strength of 310 Newton per mm square. Okay, full stop. Assuming an FOS of 2, determine the diameter of the bar. Assuming an FOS of 2, determine the diameter of the bar. Finished? Noting down?
So can you repeat the from endurance limit?
Endurance limit of 280 megapascal, 280 megapascal, and an yield strength of 310 Newton per mm square. Yield strength, sigma y. Yield strength of 310 Newton per mm square, comma, assuming an FOS of 2, determine the diameter of the bar. determine the diameter of the bar. Okay. Mulepati?
Yes, sir.
Mulepati, are you there?
Yes, sir.
Mulepati, you are there?
Yes, sir.
Yeah, read the problem.
The piston rod of steam engine is subjected to a completely reversed load of 40 kilonewton.
Yeah.
The material has endurance limit of 280 megapascal and an yield strength of 310 Newton per millimeter square. Assuming an FAS of 2, determine the diameter of the shaft.
Okay, of the bar, right. So the piston rod of the connecting rod of a piston rod of a steam engine. Okay, so piston rod of a steam engine, this is the piston and this is the piston rod of a steam engine. So this piston rod will make back and forth like that. That means the piston rod is subjected to alternative tensile and compressive stress, that is axially loaded member, right? So the rod is going to be axially loaded member. So the load varies from a maximum of 40 kilonewton to a minimum of 40 kilonewton again. Okay. So alternatively it is subjected to tension and compression, right? So therefore it is completely reversed case wherein it will be subjected to alternative tension and compression. Or if you take the other way of our regular engine, so the connecting rod is subjected to, as it goes to TDC and VDC, so it is alternatively subjected to tension and compression. Okay, of loads just given you, it is to be equal to 40 kilonewton load. And endurance strength he has given you in the problem is 280 Pascal. And an yield strength of the material of the rod is 310 Newton per mm square. And the factor of safety to be considered is given you to take as 2. So it is subjected to alternative tensile and compressive stress and is an axially loaded member. So therefore, your sigma max is going to be F max divided by area of cross section. So area of cross section is equal to pi d square by 4, and d is what we are expected to find out, that is diameter of the bar. So keep all the things, all the parameters in terms of A, and that's going to be for maximum 14 to 10 power 3 by A. This is sigma max. What is the sigma minimum then? Sigma minimum will be equal to minus 14 to 10 power 3 divided by A. Okay, and the sigma mean is going to be equal to 0 because 40 plus of minus 40, that is 40 minus 40, automatically it's going to be 0. And then find out sigma amplitude, that is nothing but sigma max minus sigma minimum divided by 2. So for minus of minus, that's going to be 80 divided by 2 is going to be 40. So sigma amplitude is equal to 40 into 10 power 3 divided by area of cross section. So mean stress is 0 for a completely reversed loading, and then stress amplitude is known. Okay, and come back to the Soderberg equation over here. Mean stress is 0, so this term gets eliminated. Factor of safety is known. Endurance strength is known to be 280. Stress amplitude is 40 into 10 power 3 by A. KFT, if not given, we take it as 1. And what are the values of ABC that we need to take? A to be equal to for
0.85.
how much?
0.85 for axial loads.
For axial load, what it is? Please check.
So it's A is 0.85 for axial loads.
For axial, okay. So 0.85, 0.85, and 0.85. Substitute these values, get the value of area of cross section, and in turn get the value of diameter. Okay. Please get me the value of diameter. That is 1 into stress amplitude is 40 into 10 power 3 divided by A, and here it is going to be 0.85 into 0.85 into 0.85 plus 0 is equal to 1 by factor of safety. So A is equal to pi d square by 4, that is equal to how much? So therefore, B is equal to, give me this value. You should know that the piston rod is subjected to axial loading. Okay. The moment you read the problem, you should be able to ascertain that the piston rod is subjected to alternative tensile and compressive stress, which is loaded axially. Yeah, what is the value of diameter?
Diameter, I think 24.34, sir.
How much, Tarun?
24.34.
Yeah, that's correct. That is 25. What is area? Can you give the value?
Area 465.24, sir.
465.24 mm square.
In the above line, you have missed sigma minus 1, sir. Endurance.
Yes, sir.
Oh,
I
yeah.
forgot to write it.
It is 280 into 280. Yeah. Please note down. Others, please note down. Okay. We'll take up the next problem. Anybody still writing? If not, we'll move to the next problem. This was asked for 12 marks. Note down. A rough finished steel rod. Please note down. A rough finished steel rod. A rough finished steel rod having sigma u is equal to sigma u, sigma ultimate, okay? Sigma u is equal to 620 megapascal. Sigma u is equal to 620 megapascal, comma, sigma y is equal to 400 megapascal. That is yield stress, 400 megapascal, and sigma endurance. And sigma endurance is equal to 345 megapascal. 345 megapascal is subjected to completely reversed. Is subjected to completely reversed. Is subjected to completely reversed bending moment of. Completely reversed bending moment of. Completely reversed bending moment of 400 Newton meter. 400 Newton meter. That is 400 into 10 power 3 Newton millimeter. Completely reversed bending moment of 400 Newton meter. So therefore, your Mmax is going to be plus 400 into 10 power 3. M minimum will be minus 400 into 10 power 3. Full stop. Determine the diameter of the rod required. Determine the diameter of the rod required. Determine the diameter of the rod required based on a factor of safety of 2.5. Based on a factor of safety of 2.5. Based on a factor of safety of 2.5. Akram Anwar. Akshat? Yeah, Chinmay?
Yes, sir. Yes, sir.
Get the problem. Others, please follow. Yeah.
A finished steel rod having sigma U is equal to 620 MPa, sigma
Yeah.
Y is equal to 400 MPa, sigma
Okay.
minus 1 is 345 MPa is subjected to completely reverse bending moment of 400 Newton meter. Determine the diameter of the rod required based on an FOS of 2.5.
All right. So it is subjected to M max of plus 400 into 10 power 3 Newton millimeter and M minimum of minus 400 into 10 power 3 Newton millimeter and FOS is equal to 2.5. Correct? This is what is given to us. So therefore you have got bending moment and bending moment. So find out sigma max, that is equal to M max divided by section modulus. And since diameter is to be found out, you need not have to have pi d cube by 32 here, keep z as it is. So that's going to be 400 into 10 power 3 divided by z. Sigma minimum is equal to M minimum divided by section modulus, that is minus 400 into 10 power 3 divided by section modulus. Okay, sigma mean is sigma max plus sigma minimum by 2. So 400 plus of minus. So 400 minus 400, it cancels out. So the mean stress is going to be 0. This is for completely reversed cyclic loading. And then stress amplitude is given by sigma max, minus of minus becomes plus. So 400 plus 400 divided by 2 is going to be 400 into 10 power 3 by section modulus. That is the stress amplitude. Okay. Substitute the values of yield, then endurance, KFT you can take it as 1. A is for bending. What is value of A? What is the value of A for bending?
1.
Yeah. A is equal to 1. B is equal to, C is equal to 0.85. You can take and substitute in the equation. Find out diameter using, since you are given with both ultimate stress and yield stress, you have to find out diameter using both Soderberg relation and the Goodman's relation. For Goodman's relation, replace yield stress by ultimate stress. Get me the diameter from Goodman and Soderberg. Okay, solve this problem and give me the value. G from Goodman is equal to, give me this value. Please solve and give me the value. Others you have to involve.
Then in these problems, sir, the values of sigma m is going to be 0.
Yeah.
So the diameter will be same.
That does not come at all into picture. That's correct.
So it will be 34.44.
It is 34.44
mm.
Yeah, that's correct. 34.4, that is 35 mm in both cases because your mean stress is 0. So yield or ultimate does not. Why I am taking this route is because you can have the same procedure for the problems that we have solved so far. Okay, you can say mean stress you find out and make it 0, then automatically it will become easy. Okay.
Yes.
Yeah. Others, did you get this value? 35?
Yes, sir.
Okay, excellent. We'll take up this problem. This was asked for 8 marks in your examination. Please take this problem. the maximum pressure in the cylinder. Anybody needing time to complete the previous problem?
Yes, sir. 1 minute.
So 1 minute.
Yeah. That's why you should come out and say, please wait. I can wait, otherwise I'll not know. So mean stress is 0. So substitute mean is equal to 0. So for both Goodman and Soderberg relation, it's going to be 35 mm only, because mean stress is 0. Whether I use yield or ultimate, this part of the equation will vanish. So what you have is KFT into sigma A by ABC into endurance is equal to 1 by factor of safety. So you will get same dimension in both cases, either way. So you should get 35 mm rounded off value for the shaft diameter.
Done, sir.
Yeah. Take down this problem. This was asked for 8 marks. The maximum pressure in the cylinder. The maximum pressure in the cylinder the maximum pressure in the cylinder of a double acting type. Double acting type. Double acting type is 0.9 megapascal. Is 0.9 megapascal. Full stop. The bore of cylinder is the bore, B-O-R-E, bore of cylinder is, the bore of cylinder is 500 mm in diameter, 500 mm in diameter, 500 mm in diameter, full stop. What should be the diameter of the piston rod? What should be the diameter of the piston rod? What should be the diameter of the piston rod if there are no stress risers? If there are no stress risers, that means you are asked to neglect stress concentration. Okay? If there are no stress risers and column actions, full stop. Take FOS as 1.75. Take FOS as 1.75 based on Soderberg's criteria. Based on Soderberg's criteria. Full stop. Ultimate tensile strength of material. Ultimate tensile strength of material of piston rod is 1750 megapascal. 1750 megapascal. Full stop. Choose a modifying factor of 0.85, 0.85 for the type of loading, comma, 0.85 for size, 0.85 for size, and 0.78 for surface effects. 0.78 for surface effects. 0.78 for surface effects. Okay. Ritik Shah, are you there? Ritik Shah. Jayant?
Yes, sir.
So I'm there.
Jayant, can you please read the problem?
Sir, I didn't
Sir.
get the first line.
Sir, Ritik Shaw, I'm there.
Hey, Ritik Shah, you have to respond fast, man. Huh? Yeah. Ritik Shah, read the problem.
Yes. The maximum pressure in the cylinder of a double acting type is 0.9 megapascal.
Okay.
The bore of a cylinder is 500 millimeter in dia.
Okay.
What should be the diameter of the piston rod if
Yeah.
there are no stress arises and column actions?
Correct.
Take FOS equals to 1.75.
Yeah.
Based on, I missed that. Something,
Soderberg's
sir.
criteria. Soderberg's criteria.
Yeah.
Yeah.
An ultimate tensile stress of material is 1750 megapascal.
Okay.
Choose a modifying factor of 0.85 for
Yeah.
the type of loading,
Okay.
0.85 for size,
Yeah.
and 0.78 for surface effects.
So what are these three values? 0.85 is what? First one. 0.85 for loading.
Yeah, for type of loading, sir.
So what is the value there? Is it the value of capital A?
Um,
0.85, I can take it to which parameter? Jayant, to which parameter take 0.85 for loading?
So it's B, sir.
Yeah.
B.
What is it for 0.85 for size?
That's the value of capital B, sir.
Yeah. Then what is it for loading?
So loading is 1. No, 0.85 we'll take the
0.85. And 0.78 is for which parameter it should take?
capital C.
Capital C. Yeah. Others, please now look into the problem now. So there is a double acting cylinder, right? So there is a cylinder. The engine cylinder I will take. Okay. So there is piston and there is connecting rod. Okay. So it says according to the problem, there is a pressure that is developed equal to how much? A pressure of 0.9 megapascal and the diameter of the cylinder is 500 mm, correct? So there is a pressure, there is 500 mm diameter acting over which the 0.9 megapascal is acting over a diameter of 500 mm. So you can find out what from these two parameters, what is that you can find out? What is it that you can find out from this parameter? You have a diameter over which a pressure of 0.9 megapascal is acting. I can extract one parameter out of these two. What is that? Yeah, what is that?
Sigma.
Yeah? Yeah, Tarun, what can I extract from pressure and diameter of that?
Stress values.
Yeah?
Stress in the force, maximum force that is occurring over there.
Pressure is equal to force by area of cross section. All right.
Yes, sir.
So you are given the pressure that is acting over a diameter of 500 mm. All right. So pressure is known. I can find out area of cross section. So from there I can extract the value of force that is acting. So therefore force is equal to 0.9 Newton per mm square into pi d square by 4. This will give me the value of force that is acting. This force is taken up by this rod over there. So therefore, this rod is subjected to alternatively the F max and F minimum with positive and negative signs. Are you there with me? Are you there? So first thing is you have to extract the force that this piston rod which is subjected to. So the engine piston rod is subjected to alternative tensile and compressive stress. So F is going to plus value is max, negative with negative sign is the minimum value. I can get the value of force here. All right. After that, you are given with the ultimate strength value only, correct? And of course, factor of safety is given as 1.75, and you are given with the value of A to be equal to 0.85, value of B is equal to 0.85, and value of C is equal to 0.78, which is surface finish effect. And you are given with ultimate strength value of 1750 megapascal. So, I am not given with, or we are not given with the values of field stress and endurance strength over here. So, in such cases, what we can take for practical purposes is sigma y to be equal to 0.75 times sigma u, and sigma endurance we can take it as 0.5 times sigma u. If not given, we can take these values for practical purposes. That is, endurance strength is 50% of ultimate strength, yield stress is 75% of ultimate strength. Is that okay? Now can you solve the problem? So you can find out yield stress, you can find out endurance stress, ABC values are given, factor of safety is given, and we can extract F from here. Since it is subjected to axial loading, what you are going to have is sigma is given by F by area of cross section. So here, area of cross section is of piston, not the cylinder bore here. Okay, you need to find out diameter of the piston rod. That is, A here is going to be pi d square by 4. So this I can take it as capital D here. So this I take it as capital V. D, that is the diameter of the engine cylinder, whereas small d is diameter of the piston rod, which is what we need to find out after getting the value of F. Could you understand this? Could you understand how to solve this? Solve and get me the value of diameter. Solve and get me the value of diameter. Akram Anwar. Are you there? Nadilla? Oh, mic is not working. Okay. Okay, I want the value of diameter to be given. I'll ask somebody in the process. So please give me the value of diameter. Find the value of F and then the diameter. Answer your roll call. 1.
Answer.
2. Abhishek GL. 3. 4.
Present, sir.
5. 5. 6 present. 7. Jadhav. 8.
Present, sir.
9. Nambiar. 10.
Present, sir.
11. Ibn. 12.
Present, sir.
13. 14.
Yes, sir. Present.
15.
Present, sir.
16. 17.
Present, sir.
18.
Present, sir.
19. 20.
Present, sir.
Is it 20 or 19?
20, sir.
Huh? Which USN
20,
is
sir.
20? 21,
Yes, sir.
22,
Present, sir.
23,
Yes, sir.
24, 25, 26, 27,
Sir, 20. Sir, 24, sir.
huh?
Sir, 24 present, sir.
Where
24 present.
did you go? Huh? 26, 27, 30, 31, 32, 33,
Present, sir.
34,
Yes, sir.
35, 36,
Yes, sir.
38, 39, 40,
Yes, sir.
41, 42,
Yes, sir.
43, 44,
Present, sir.
46, 47,
Yes, sir.
48,
Yes, sir.
49,
Yes, sir.
50,
Yes, sir.
52,
Yes, sir.
53,
Yes, sir.
54, 55, 56,
Sir.
57, 58, 59, 60,
Yes, sir.
61, 62,
Yes, sir.
63,
Present, sir.
65, 66,
Present, sir.
67, 400,
Yes, sir.
Mahesh Madiwal, Nishant, Ramesh, Shashank. Yeah?
Yes, sir.
Who is that? Shashank?
Prashant, sir.
Akshat?
Present, sir.
Sautrik Rai?
Present, sir.
Mahima? Mahima Raj? Srivatsan?
Present, sir.
Suman Xavier? Madan Kumar? Manu Eke?
Yes, sir.
Shadab Khan? Ganesh R? Vijay Kumar?
Yes, sir.
Rishi? Zahir Hussain?
Present, sir.
Yeah, what is the value of F? What's the value of F?
176714.59.
Yeah. 176
714.
6714.6 no 6714.6 Newton. Okay. What is the diameter now?
29.
29. Yeah, that's correct. That is 28.26 we get. That is 28.3 rounded off to 29 mm. That's correct. What you get is 29 mm. Okay. So here, so plus 176,714.6 will give you sigma max, and F minimum will be minus 176,714.6. So that will give you a sigma minimum. Mean is 0. So this will, the entire thing will go. All right. So ABC values are known. KFT taken as 1. Amplitude you can find out. And then factor of safety is 1.75. Diameter what you get is 29 mm. Anybody? Any doubt in this? Any doubt?
So what is the area?
Yeah?
Area.
Yeah, Charishma, what is the doubt?
The area of the thing, so what is the value?
Area is 627.15 mm square. Here what you get is 627.15 mm square. So from there, you are going to get the diameter to be equal to 29 mm. Okay?
Okay, sir. Okay, sir. Got it.
Yeah. Anybody needing time to note it down?
Yes,
1
sir,
minute.
yes.
Yeah. Do it. Please do it and solve the problem. Nishna?
Done, sir.
Yeah. For second test, I have uploaded case study material. Okay. Yeah. In Google Classroom. Are you there? Are you aware of it? Yeah.
Yes.
Yes, I am.
It's there, no? And syllabus for second test is up to what we have done today. Okay. Up to this, you will have syllabus. So it consists of theories of failure, then design for impact strength, and design for fatigue strength up to whatever that is done today. Is it okay? Fine. Okay. So tomorrow we'll start with notch sensitivity factor, that is designed for fatigue strength in the presence of stress concentration. Is that okay? So we are going to have the data handbook which contains the graphs for stress concentration, K sigma. Okay. Stress concentration factor we extracted from the data handbook. So please keep that data handbook with you, and we'll solve the problem based on stress concentration in fatigue design. Is that okay? Fine.
Yes, sir.
Okay, Mr. Right.